Today's lesson on Capecchi's Corner, we are going to solve linear systems of equations using the substitution method. It is a 2-day lesson and today is day 1. The substitution method is an algebraic method of solving a linear system. In the last lesson, we solved a system by graphing, and this is one way you could do it algebraically. Here are the steps that you're going to want to reference as you're solving a system using substitution method. The first step is solve one of the equations for one of its variables. I call that the revised equation. So for instance, if your equations are using the variables x and y, you're going to solve one of those equations for either x or y. The second thing you're going to do is you're going to substitute your expression from step 1 into the other equation and solve for the remaining or the other variable. The third step is you're going to substitute the value from step 2 into the revised equation from step 1 and solve. This is the solution to the linear system. So at this point you have solved for both x and y. You're then going to put in the solution into coordinate form. My last step is to check the solution in each of the original equations. So I'm going to take my values from x and y and I'll substitute that into each of my original equations. If I get true statements in both equations, I know that I correctly solved the system using substitution method. Okay, I'm ready to practice one, so I'm going to solve the linear system using substitution method. Now remember, my first step says I'm going to solve one of the equations for one of its variables. So we want to get x or y by itself in either of my equations. I notice in my first equation, I already have x by itself. So I'm going to actually call this, I don't have to do anything with this, it's already done. This is what I call my revised equation. So I'm going to use that to go into the other equation, which is my next step. So now, everywhere I see an x, I'm going to substitute in 3y minus 13. So I have 2 times the quantity of 3y minus 13 plus 2y is equal to negative 10. So what I did was, on my equation here, I said x is the same as 3y minus 13. So everywhere I saw an x in my other equation, I substituted in that expression 3y minus 13. Now, if you notice at this point in my equation that I'm going to work with, I only have y's. I don't have any more x's, which is what I want. Now I can do my algebra, and I'll be able to solve for y. So I'll distribute, and I get 6y minus 26 plus 2y is equal to negative 10. Now here's my wall. I have 6y and 2y is on the same side of my wall, so I just combine those like terms. I get 8y minus 26 is equal to negative 10. So now again, I'm trying to isolate y, so I'm going to add 26 to both sides, and I have 8y is equal to 16, divide both sides by 8, and y is equal to 2. So I have my first value of y. Now I need to find x. So this is where I'm going to go all the way back to my revised equation, which I started with, which is x is equal to 3y minus 13, and now that I have a y value, I can substitute that back in. So I have 3 times, remember y is equal to 2, 3 times 2 minus 13. So I have x is equal to 6 minus 13, so x is equal to negative 7. Now at this point, my solution, I know what my solution is because I have my x and my y. So my solution to my linear system is negative 7, 2. Now my last step is to check my solution. So I'm going to substitute always back into the original in math. And the reason we do that is when you substitute into the original, you're sure that you didn't make an algebraic mistake along the way in order to prove that your solution is correct. So I have x is equal to 3y minus 13 is my first equation. So I'm going to substitute my values, and negative 7 is equal to 3 times 2 minus 13. So that's negative 7 is equal to 6 minus 13, which is true. Now I'll do the same thing with my second equation. So I have 2x plus 2y is equal to negative 10. I'll substitute my values in, so I have 2 times negative 7 plus 2 times 2 is equal to negative 10. So it gives me negative 14 plus 4 is equal to negative 10, which is a true statement. So now that I've checked my solution into both original equations, I know that I have my correct answer. So negative 7, 2 is my solution to my linear system, which also means if I were to graph these two equations, that's my point of intersection. In our next system, we have the equations 4x plus y is equal to 12 and negative 2x minus 3y is equal to 14. Now again, we have to get one variable by itself in either of the equations. So that means either x or y in the first equation or x or y in the second equation. Now if you look at the first equation, we have y has a coefficient of 1. So that's actually going to be the easiest one to isolate. So I'm going to subtract 4x from either side. And I have y is equal to negative 4x plus 12, which, remember, this is the revised equation. That's my revised equation. So in my other equation, there's my y. I'm going to substitute everything in from my revised equation into that y there. So that gives me negative 2x minus 3 times the quantity of negative 4x plus 12 is equal to 14. So if I distribute, I get negative 2x plus 12x minus 36 is equal to 14. I'll combine my like terms on the left-hand side of my wall, which gives me 10x minus 36 is equal to 14. Add 36 to both sides, and I have 10x is equal to 50. Divide both sides by 10, so x is equal to 5. Now what I'll do is I'll take this x value, substitute it back into my revised equation to find my value for y. So that gives me y is equal to negative 4 times 5 plus 12, which gives me y is equal to negative 20 plus 12, so y is equal to negative 8. So now my point of intersection, or my solution to the linear system, is 5, negative 8. I can check that again to make sure I'm accurate. So again, here's my first equation, 4x plus y is equal to 12. I'll substitute my values in. Here's x and here's y. So I have 4 times 5 minus 8 is equal to 12. This gives me 20 minus 8 is equal to 12, so that works. I'll try my other equation, which is negative 2x minus 3y is equal to 14. Again, substitute my values in, so I have negative 2 times 5 minus 3 times negative 8 is equal to 14, which gives me negative 10 plus 24 is equal to 14. Now, because I have a true statement for both equations, it means that the coordinate 5, negative 8 is the solution to my linear system, which also means it's the point of intersection if I were to graph these two lines. My next set of equations are a minus 2b is equal to negative 25, and 3a minus b is equal to 0. Now, instead of using x and y this time, we have a and b as our variables. We're going to solve this system the same way using substitution. So the first step is I'm going to isolate a variable. Now again, I have a with a coefficient of positive 1, so that's going to be the easiest one to solve. In my second equation, I do have negative b, which I could use also. I would just have to remember to divide everything by a negative number. But I'm going to go with a in my first equation. So I'm going to isolate that. So I'm going to add 2b to both sides. And I have a is equal to 2b minus 25. So again, that becomes my revised equation. So I will use that later in my solving process. So now I'm going to substitute in my second equation. Everywhere I see an a, I'm going to substitute the expression 2b minus 25. So I have 3 times the quantity of 2b minus 25 minus b is equal to 0. So I'll distribute. I have 6b minus 75 minus b is equal to 0. Again, there's my wall. Combine my like terms, so I have 6b and b, and negative b, that becomes positive 5b minus 75 is equal to 0. I'll add 75 to both sides, and I have 5b is equal to 75. So in my last step, I have to divide both sides by 5, and I have b is equal to 15. So now what I'm going to do is I'm going to substitute that back in again, back to my revised equation. So I have a is equal to 2 times 15 minus 25. So a is equal to 30 minus 25, so a is equal to 5. So it looks like my solution to this linear system is 5, 15. But again, I'm always going to check it just to make sure. Now, why did I put the 5 first, and not the 15? Because alphabetically a comes before b. Just like you do with another coordinate, you list x before y because x is alphabetically before y when listed. So now I'm going to substitute back in. So my first equation of a minus 2b is equal to negative 25. So I have 5 minus 2 times 15 is equal to negative 25. So 5 minus 30 is equal to negative 25, which is correct. My second equation, I have 3a minus b is equal to 0. So I have 3 times 5 minus 15 is equal to 0. So 15 minus 15 is equal to 0. Again, because I have true statements, I know that my solution to my linear system is 5, 15, and I know if I were to graph these lines that that's the point of intersection. In our last example for today, we have y is equal to 3x minus 2 and y is equal to 2x minus 5. Now our first step was always to isolate one variable in one of the equations, but if you notice, y is isolated in both equations. So here's the interesting thing about that. If y is equal to 3x minus 2 in the first equation, and y is equal to 2x minus 5, doesn't that mean that 3x minus 2 and 2x minus 5 are equal to each other? It's a different form of substitution. It's basically saying that they're the same because they're both equal to y. So technically, if this is my expression and I'm substituting it over to the other equation, I can simply say 3x minus 2 is equal to 2x minus 5. They're both equal to y, so when I substitute, this is the equation I get. Now I have to isolate my variable. Let's solve for x. So I have x minus 2 is equal to negative 5. I'll add 2 to both sides, and I have x is equal to negative 3. Now I can substitute x is equal to negative 3 in either of my equations, so I have y is equal to 3 times negative 3 minus 2. So I have y is equal to negative 9 minus 2, so y is equal to negative 11. So it looks like my solution to my linear system, which is negative 3 and negative 11. So again, though, we'll double check it. So my first equation, I have y is equal to 3x minus 2. So I'll substitute, again, here's my values for x and y. So I get negative 11 is equal to 3 times negative 3 minus 2. Negative 11 is equal to negative 9 minus 2, which is correct. I'll do the same thing for the other equation. So I have y is equal to 2x minus 5. Substitute negative 11 in. 2 times negative 3 minus 5. So I have negative 11 is equal to negative 6 minus 5, which is true. So again, negative 3, negative 11 is my solution to my linear system, and it is the point of intersection if I were to graph these two lines.